Hello juniors, today we're going to see electronic assignment number 16, which is about expectation and variance of a binomial distribution. If you remember the concept of expectation from random variables, you will remember that it is the average value that I would expect to obtain when I repeat a specific experiment multiple times, right? So we're going to see that same concept, but now applied to binomial distribution. And we're going to see a new concept called variance, which is something that you already know from statistics. So it says expectation and variance of a binomial distribution. Two objectives for today's class. The first one, define and calculate expectation and variance of a binomial distribution. And number two, apply binomial distribution to solve problems. Okay, so I prepared an example here in order for you to visualize what this is about. It says, let's suppose we're in a classroom with 20 students, where 14 are girls and 6 are boys. What is the expected number of boys I will get if I randomly choose 10 students in the class? So if we first of all calculate the probability of getting a boy, of picking a boy, it would be 6 out of 20, right? Which if we simplify gives us 3 out of 10. So if I pick 10 students at random, how many of them would I expect to be boy? So in order to calculate that, we need to multiply the number of students we're picking randomly times the probability of picking a boy, right? So that's exactly what we did here, and we get 3. So out of the 10 people I select, I expect 3 of them being boys, right? So that's what expected value means. Then it says, for the binomial distribution, where x is binomially distributed with n trials and a probability of success of p, the expectation of x is calculated in that way. It's n times p. The total number of trials times the probability of success of a specific event, right? Just as we found in this case. So n is the number of trials, p is the probability. That's something you should already know. Then it says, this, however, doesn't mean that we're always going to get 3 boys every time I pick 10 students from the class. This is just an expected value. If the experiment is repeated, I could sometimes get 0, 1, 2, 4, or any other different amount of boys, right? This difference from the expected value is what we know as variance of the binomial distribution. So this is a new concept, right? If x is binomially distributed, then the variance of that variable x is found by applying this formula, n times p times q, where if you remember, q is a probability of failing, right? So it is found by doing 1 minus the probability of success, okay? Then it says you can find the standard deviation, remember sigma notation, by taking the square root of the variance. That's something you already know, right? We're not going to see where this formula comes from because that is out of the IB program. Maybe if you study something related to statistics or probability, maybe you'll see the deduction of this formula, but we're not going to cover this now. Okay, so in general, for the binomial distribution where x is binomially distributed with n number of trials and a probability of success p, the expected number of x is found by doing this. Expected value is n times p. And the variance of x is found by doing n times p times q, where q is 1 minus p. So if you remember, the variance is standard deviation squared. So if I want to find the standard deviation of this information, I just need to take the square root of the variance. Okay? Then an observation here, the expectation EX is also called the mean of a binomial distribution. Sometimes in IB exams, you would just be asked to find the mean of a binomial distribution, and you should understand that the mean is the same as saying the expected value of x, okay? Just to let you know, all of these formulas that we have just seen are in the formula booklet. Let me show you. If we go to topic, I think it was topic 3 or 4. Topic 4. This one, yes. If we go to topic 4, you would see that here you have binomial distribution, and here you have mean of a binomial distribution and variance of a binomial distribution, which is what we just saw. Okay, so the two formulas are in the formula booklet. You don't need to memorize this. Okay, so let's see some examples to see how this is applied. It's actually pretty easy. It says, in a large company, 40% of the workers travel to work on public transport. A random sample of 15 workers is selected. find the expected number of workers in this sample that travel to work on a public transport and the standard deviation. Okay, so first of all, we're going to identify our information. We know that 40% of workers travel to work on public transport, right? So that would be our probability of success. Probability of success is 0.4. Remember, you should always write this as a decimal number, not as a percentage. So our success is that they go on a public transport. That means that failing would be not going on a public transport, right? And this is a binomial distribution because it's either you go on public transport or you do not go on public transport. Okay, then it says a random sample of 15 workers is selected. That means that our universe, or our number of trials, would be 15 in this case. Okay, so find the expected number of workers. The expected number, as you know, is EX, the expected number. And from this theory, we have learned that EX is found by doing n times p, right? So this would directly be n times p, which is equal to 15 times 0.4. And this is equal to, if you do this in the calculator, you should get 6 workers. Okay, so I expect that out of those 15 people, 6 of them will go on a public transport, right? That's the expected value. And then we want to find the standard deviation. To find the standard deviation, I should first find the variance of this variable, which is found by doing n times p times q, or times 1 minus p, as it is in the formula booklet. So if we calculate this, this would be equal to, let me write here, variance of x. N is 15, probability of success is 0.4, and 1 minus 0.4 is 0.6, so times 0.6. So if you calculate all of this, you'll get a result of 3.6 workers. 3.6 workers. Yes, that's fine. So that's the standard. So that's the variance, right? So if I want to find the standard deviation, which is sigma, I just need to take the square root of this number, square root of 3.6, and this gives us a result of 1.90 if we round it to 3 significant figures, workers. Okay, so this would be the standard deviation. Now, what does this standard deviation mean? It means that the standard deviation is an average of the difference from the mean value, right? So if I repeat this experiment multiple times, I won't be getting 6 workers every time, right? Just as I told you before. But if I consider this standard deviation, and usually we consider one standard deviation below the mean, I'm right here, 6 minus 1.990. And then we have 6, which is the expected value, and one standard deviation above the mean. Then it is very, very likely that we would be getting values which are inside this range of values, right? If I calculate this, this would be 4.1, 6, and 7.9. So if I repeat this experiment multiple times, the most probable thing is that I will be getting a range between these values of workers who go on public transport, okay? That's why the standard deviation is also important to consider. Okay, so I hope this is clear. Let's see one last example, and then we're done for this electronic assignment. It says, for this one, we would need to use calculator, okay? So you can have it with you and follow the instructions. It says, a biased dice is thrown 50 times, and the number of sixes seen is 12. If the dice is thrown a further 12 times, find A, the probability that a 6 will occur exactly twice, B, the expected number of sixes, and C, the variance of the number of sixes. Okay, so we would have to, first of all, determine our probability of success. Since the only information we have for this particular problem is that the biased dice was thrown 50 times and we got 12 sixes, then the probability of success for getting a 6 would be found just by using this information, okay? Because we don't have any other information to find the probability of success. So this would be 12 out of the 50 throws, we got a 6, okay? So we would see, can we simplify that? I think we cannot simplify. Yes, we can simplify that. This is 12 divided by 50, which is 6 over 25, right? If we divide by 2. So this is our probability of success. Now, it then says if the dice is thrown a further 12 times, so we're considering this situation where we throw the dice 12 times, right? So our number of trials, n, would be equal to 12 in this case. So now we can work with the problem. We already have the probability of success and we have the value of n. So for part A, we're going to say that what is the probability that a 6 will occur exactly twice? So you see that we're talking about binomial distribution first of all, because it's either getting a 6 or not getting a 6, right? So that's binomial. So we need to find the probability of getting 2 6s exactly. So probability of x equals 2, right? If you remember from binomial distribution, this is the same as saying, if we apply the formula, it's a number of trials, which is 12. We want only 2 6s, times the probability of success, which is 6 over 25, to the power of 2, right? Times the probability of failing, which would be 19, right? 25 minus 6. Yes, 19 over 25 to the power of 10, which is 12 minus 2. Okay? But instead of doing all of this, you can do all of this in the calculator as well. But remember, we have a shortcut for doing this in our calculators. Let me quickly remind you how to do that. So if you take a look at the calculator, we are going to menu statistics, right? And then we're going to click on distribution, which is F5. We're talking about a binomial distribution, so you click F5 again. And in this case, since we want exactly 2 6s, we're going to click on BPD. Okay, so BPD. Our X value would be, in this case, 2. Number of trials is 12. And the probability of success is 6 divided by 25. Okay, so there you have. This is the probability of obtaining exactly 2 6s, right? This is 0.244. We round it to 3 significant figures, okay? So this would be the result. Then it says, for part B, find the expected number of 6s. Okay, so the expected number of 6s, remember, this is EX, right? So we're going to apply the formula. EX is equal to n times P, where n in this case is 12, and the probability of success is 6 over 25. We can do this in the calculator. We would have times 6 over 25. This is 72 over 25, which if we write it as a decimal number is 2.88. 2.88. So we would expect 2.88 6s, right? That is that if we throw this dice 12 times, then 2.88 times we would get a 6, right? Obviously, this number needs to be an integer number because we cannot get 2.88 6s. So we would expect getting maybe 3 or 2 6s, right? Most likely 3 because we're closer to 3. But that's the expected number. And then the variance, it says the variance of the number of 6s. So we just apply the formula, variance of this variable. The variance is found by doing n times p times q, right? So this is n times p times q, and this is equal to 12 times probability of success, which is 6 over 25, times q, which is 19 over 25. If we multiply all of this, we're going to get the variance. This is 12 times q, 19 over 25, and this gives us a result of Let me write the whole fraction first. 1368 over 625, which is equal to 2.1888. That's the exact number. And okay, we're only asked for variance, so this would be the result. Okay, variance does not have any unit of measurement, so we would just leave it like this. If we were asked to find the standard deviation, we would just take the square root of that number, and that would be the standard deviation. Okay, so this is pretty easy, people. Let me write this here. Variance of x. This is pretty easy, people. It's just applying formula. There's nothing very difficult out of this. So I hope this was clear, and if not, please let me know. Thank you for your attention, and see you.